Dear friends, welcome back again. My name is Johannes. In this video, I am going to show you some illustrative examples on geometric elements of open channel, normal depths, and also some circular channel, trapezoidal channel, rectangular channel, etc. And also how you apply on calculator iteration system. So let us see now. You have some geometric. So I think we have geometric elements of open channel flow. So let us see this example. A trapezoidal channel with bottom dimension, which is 4 meter, free surface width of 10 meter, and flow depth of 1.8 meter, discharges water at a rate of 90 meter cube per second. If the surface of the channel are lined with rubber masonry having Manning roughness coefficient of 0.025, determine the cross-sectional area and weighted perimeter of the channel, and the hydraulic radius of the channel, and also the slope of the channel, and the length of the channel per 10 meter of elevation drop. So I hope you have some given parameters. You have bottom dimension is given. So this is the geometry of the channel. You have 4 meter and 1.8 meter depth, and top dimension or free surface width of water surface, you have 10 meter, and also discharge 90 meter cube per second, and Manning roughness 0.025. So you are asked to determine cross-sectional area. What is the cross-sectional area of this trapezoidal channel? So from geometry, we know that the area of trapezoidal section B1 plus B2 over 2 times H. We know this. If M is not given, you can apply geometry. So you have half base 1 plus base 2 times H. Or if you have side slope M, you have this formula again. B plus My times Y. If M horizontal, 1 vertical side slope is given, you can use this one. Otherwise, we can apply this one since you have total B2, this one, this is B2, this is B2, and this is B1, clear? This is B1, so you have B1 plus B2 times H. So let us see the solution. You have 12.6 meters square. So this is the area of the channel, the cross-sectional area of the channel. So what is the weighted perimeter? Second problem. Weighted perimeter is nothing. B plus 2y square root of 1 plus m square. So this is one formula. Or B plus 2 times side lengths. So side lengths means from this up to this dimension, you can calculate. You can calculate this dimension. Since you have bottom dimension 4 meter and surface width or top dimension 10 meter, you can subtract 10 minus 4, you have 6. So 6, if you have 6, then you have 3 meter on both sides of the triangular shape. So just let me draw. Then you can just put the dimensions 3 meter. Then you have 1.8 here. Then you can just, this is Pythagoras theorem you can apply. So L will be this one, 1.8 square plus 3 square under square root. So you get 3.49 meter. So this is the slant length. So you can apply this formula, or you have to calculate M, side slope, you can compute. Let us see side slope. Side slope, just slope is nothing, vertical drop divided by horizontal distance. So since you have vertical drop 1 into M from the above picture, from this one, you have 1 to M, slope 1 to M, which is M horizontal, 1 vertical. So you can just use this equation 1 over M. So if you go 1.8 meter depth and horizontal 3 meter, what will be the side slope? So just crisscross, you can multiply this crisscross. Then once crisscross, M will be 1.67. So having this, you can calculate now. Perimeter is B plus 2 times Y square root of 1 plus m square. So you get 11 meter. Or you can apply the previous formula, b plus 2 times side lengths or slant lengths of the trapezoid section. So you have L already, we compute 3498, then approximately you can have 11 meter. So the same result with this one. So let us see now hydraulic radius. Hydraulic radius, geometric elements of open channel, which is area over weighted perimeter. So area already computed above and perimeter already computed here. Then you have 1.145 meter. So this is hydraulic radius of the channel. And the slope of the channel, how do you get? Which is the bed slope of the channel. Since you have channel like this, then what will be this slope? You have to compute this slope, which is flow is going like this. So what will be the gradient or the bed slope of the channel? So from Manning equation, you have this equation, A over N R2 third times square root of S naught or bed slope. This is side slope, but here bed slope of the channel. So you have just discharge is given Q 90, area over Manning roughness, rubber mass Mori, and hydraulic radius already computed. Then S naught you can calculate. S naught is 0.0266, which means 1 into 37.59. For every 1 unit drop, you will have 37.59 distance. So length of channel 13 meter. Elevation drop. Slope is nothing, drop over horizontal distance. Then you simply substitute the values. So horizontal length, what is the length of the channel for this 10 meter drop? So drop you can substitute here. Slope already you have here. Then horizontal length will be computed 375.94 meter. So this is a drop. Okay. So second example is uniform flow. So in this example, I am going to show you some iteration using calculator. So calculate the uniform water depths or normal depths of an open channel flow to convey a discharge of 10 meter cube per second. To convey this discharge with Manning roughness coefficient of 0.014 and bed slope given. If the channel is rectangular with bed width of 4 meter, what will be the normal depth? If the channel is a trapezoidal section with bottom dimension 4 meter, side slope 2 horizontal, 1 vertical, what will be the normal depth, the uniform flow depth? So this is the side length, which is y square root of 1 plus m square. The same is true for this one, because you have b here, my, then top dimension, then you have slant length. Okay. Okay. For rectangular channel, from Manning's equation, you have this formula, Manning equation. So as I said previously, for rectangular channel, you simply substitute area and hydraulic radius, then bring Q into this Qn over radical S naught. Then if you divide B, the power of 8 over 3, everything will be cancelled out. So for rectangular channel, we have this general equation for the iteration. Just in a short time period, you can calculate N naught. So N naught is nothing, Y naught over B. So you have discharge Q already given, N already given, and also bed slope already given, then bottom dimension given. So for rectangular channel, this is the equation. So calculate N naught. So to calculate N naught, you have this one. So this actually Qn over radical S naught V the power of 8 over 3, you can have phi. From table, you can read out this one. You can read out phi from table, then Y naught over B will be taken from the table, from the same table. Let me show you table, which is for any channel, which is for rectangular channel. You don't have any slope, then automatically you can apply. So for rectangular channel, M is 0, no slope. Since it is vertical, you don't have. So M0 will go like this. So phi is, values of phi is this one. So N naught, once you calculate, for example, we have 0.17. You have 0.17 M0. You go 0.17, 0.1317, like this, around here. You see? Around here. 0.17 here, around here. So around here, you can just around this one, 0.172, around here, or next to this one, which is around here. Then you will iterate just 0.450, then it will go like this, 0.455 here, you have here. This is the second value. So you can iterate here 0.17 to something like that. So you can iterate, then you will have N naught. Then N naught will be Y naught over B. Then finally, you arrive at the solution. Otherwise, let me show you using calculator. Using calculator, how do you compute? Okay, so crisscross and multiply by reciprocal of this exponent, which is 3 over 5 on both sides. So you will have this expression. So this is the expression how to compute. Now, you have N naught on both sides of the equation or the expression. Then how do you compute using iteration? So you have this equation. You simply type this one in your calculator, but first give any arbitrary number. Type any number, say 0.85 equal to, click equal, then this number will be saved in your answer in your calculator. Then make on your calculator. Then once you make on, just you write this equation, this expression without any equal sign. You just write this one, but first you have to give any arbitrary number, say 0.85 equal to, then make on your calculator, then your calculator is saved in this answer. So if you click answer, it will be displayed 0.85. Now you just write this expression, then you simply click equal, this equal sign continuously until you get constant number. Until you get constant number, then you have just answer already in place of N naught, just click answer. You click this answer, already you have saved, then equal, again continuously by try and error. If you just click equal continuously, equal, then result will be this one. You see from table again, like this, we can read out phi. Then finally, N naught will be Y naught over B. Y naught over B is the general expression. So you can find normal waves now. So N naught, which is this one, Y naught over B. So from this, we can find Y naught or normal depths. So normal depths will be 1.81 meter. So this is for rectangular channel. You can check from table. And also for trapezoidal channel, the same approach you will follow from Manning equation. Again, we have got this general expression to calculate normal depths for trapezoidal channel. You will use this equation, which is very important. You can just apply for different channel. dimensions and also hydraulic parameters you can apply. Then just substitute again 0.173622, then equal to 1 plus m n naught the whole 5 over 3. Again, multiply both sides by 3 over 5 on both sides. If you multiply on both sides by 3 over 5, then this will be 2 over 5, because 3 over 5, if you multiply this one, 3 over 5, 3 will cancel out. Clear? 3 will cancel out. Here, automatically will be cancel out. Then you have n naught. Take this n naught here. Then be careful on brackets or braces. So you have the bigger bracket or brace. Then you have numerator. If you multiply 0.173622, the power of 3 over 5, you will have this result. Then multiplied by this symbol, you have to type 1 plus 4.472 times n naught. The whole 2 over 5, then close bracket. This is for numerator. Clear? For numerator, you have to type like this, then denominator, this will come. 1 plus m n naught. M is 2, then this is m n naught. So this is the expression. So you are going to write this expression in your calculator if you put answer. Answer, you have to give any arbitrary number. Let us see. Type any number in your calculator. Say, for example, 0.95 equal. If you click this equal, then this number will be saved in your answer, in your calculator. You can check answer equal. Then once you just save this value, then I will write this whole expression in my calculator. So let us write. You write the same expression, this expression, you write the following expression in your calculator. Be careful in the braces. So you have like this, the bigger bracket, then smaller bracket, which is numerator, which is single bracket. You can close since this is multiplication. Then once you write this expression in your calculator, you simply click equal, but you have to click answer. Already you have saved it in your answer. Then answer. Here you bring answer in place of n naught. Answer. Then equal continuously until you get constant number. Then the constant number is definitely sure it is your answer or the last iteration of your calculator. So n naught, we found this value. So once you find n naught, then you can have n naught, which is y naught over b. So crisscross this one, then get y naught, which is 1.225. So this is 1.225 result. So what does it mean? From a rectangular section, we found result 1.81. But for trapezoidal section, we found this one. For the same flow rate, for the same bottom dimension, why change? You have the same bed slope, and again you have bottom dimension and also Manning roughness the same, and flow rates the same. So the main issue is the trapezoidal channel is just a stretch of like this. Clear? But rectangular channel is this one. So due to the stretch, the water level initially here 1.81, but due to the cross-sectional shape of the channel, so it will drop. The water level will be dropped. So this is the normal depth 1.225. Okay, using table, you can just use this method, which is using a table. You have a side slope, 2 horizontal, 1 vertical. So this can be taken from Qn over root S naught b the power of 8 over 3. You can read from table. Okay, from table you can this is for M2. This is just M2. You can see you can go down M2, then you can go up to this one. So 0.173 is between this point, which is this one. So you can just interpolate. Then finally, you can find N naught. So table 3A1, you can read from this one. So I can take this just for interpolation. You can take this one. Then, so this is interpolation. So calculate now. You can calculate between 0.1722 and 0.177. Then you can iterate. Then finally, you can find this result, which is N naught will be, I think, 0.0627. So once you find N naught, then you can read finally normal depths. So normal depths will be this one. So either table or iteration, you can follow one of them. So this is just from table. So this will mean phi. This is equal to phi. Then you can read table. Then finally, this is the point, which is 0.306, etc. So you can calculate using this one. Okay, so as the exercise, you can try this one. A concrete line trapezoidal channel with uniform flow has a base width of 5 meters and a discharge of 30 meter cube per second and side slope equal to m to 1. 2 to 1. And the Manning's coefficient n can be taken as 0.015 and the bed slope is given. Calculate the normal depths, the mean velocity, and the region of the flow in the open channel. So this is the cross-sectional shape. So the same approach we will follow. Since this is trapezoidal channel, we will use this expression for computation of n naught. So once you find n naught, then you can find normal depths. You may use the table or the iteration approach. So to compute the region of the flow, you have V over square root of GD. But find first, you have Q already known, so you have to compute area. Area B plus M Y naught times Y naught. Then V is equal to Q over area, so you substitute here. D again, A over T. Then finally, you can say this is subcritical flow. We will see in the next topic. And exercise 1.2 again, a 2.6 wide rectangular channel lined with concrete, which is Manning roughness given. The bed slope of the channel is given again. If the normal depth of the flow is 1.2, calculate the conveyance of the channel, the discharge, Froude number of the flow, and the average bed shear stress. Okay, the other exercise is bottom width of the channel. Previously normal depth, now bottom width of the channel. So from this equation, from section factor, you can approach this equation or take this equation to compute bottom dimension. Take out B over Y naught, then finally you multiply this one. But try to find K naught using iteration. Okay, circular channel, I will proceed is the next slide. Thank you very much. And thanks for watching this video. So this is all about today's lecture. Hopefully you liked the video. If you have any comment or question regarding this topic, please write down in the comment section below. I will reply on it. Please like, share, and subscribe this video to get more precise lectures. Thanks.